Okay. So students, can you hear me clearly? Can you hear me clearly? Please confirm with a message. Confirm with a message. We will actually start with optics, okay? We'll actually start with optics because we drew the diagrams first because otherwise it would take a lot of time for this process. So let's start with optics. Okay, let's start with optics. Learn the theorems in optics. Finish that. Okay, finish that. Then let's move to the diagrams part. Okay. This is an English medium session. Sinhala medium sessions are also coming. Like අවශ්‍ය නම් අපි බලලා එහෙමත් කරලා දෙන්නම්. ගොඩක් වෙලාවට ඔක්කොම ඩිසයිඩ් උනේ ළමයින්ගේ රික්වෙස්ට් මත. එතකොට අර ඉංග්‍රීසි මීඩියම් ළමයින්ගෙන් තමයි වැඩි රික්වෙස්ට් ප්‍රමාණයක් ආවේ. Okay. We got the most number of requests from English medium students. That's why many a large proportion of seminars are English medium due to that reason. Okay. As many students like Sinhala medium students said that they have classes. ඒගොල්ලන්ට පන්ති තියෙනවා කිව්වා O level වල, so no big issue there. සිංහල medium ළමයි කිව්වා ඒගොල්ලන්ට පන්ති තියෙන හින්දා ලොකු ප්‍රශ්නයක් නැහැ කියලා එතන. But English medium students, a lot of them mentioned that story like they haven't covered things properly, they have issues with some areas, so many issues were mentioned by English medium students. That's why a large proportion of sessions are English. Okay, so again starting, I'm Janduleelananda, an electronics engineer and A-level physics conductor. So you will meet again if you are doing bio or maths for A-levels in physics. I'm teaching physics. So anyways, and a small explanation about what is happening here. Until now, we have discussed, we have done a sequence of sessions. We did current, for English medium students, we did current, electricity, electronics, electromagnetics. And today, just 1 hour before, we did work, power, energy, fluid and equilibrium. Okay, and equilibrium. So after that, now we are doing geometric optics, and if time permits, I'll do waves too. But we have some demonstrations in optics and waves too. I will try to go through that because more demonstrations you see, more comfortable you get with that concept because it gets into your common sense. Okay, it gets into your common sense when you see practical scenarios. Okay, so that is one of the main targets today. Okay, we are going to teach you how optics works and we are going to show you how it works. Okay, with that combined, things will go properly into your head. Okay, that is the main plan for today. Okay, so we'll see. Okay, we'll see how things happen. So let's start with the optics part. So students, just let me know if you have any issues. Okay. Yes, all the recordings will be provided. Okay, today after this session, all the recordings will be provided in the group, and we created a WhatsApp channel so that we don't have to put things repeatedly in a channel. In the channel, you can directly get things. You can see things that were like uploaded before you join the group. So it's not like a group. So we have created a WhatsApp channel too, so that it would make your life easy. So you can see all the resources in one place. We'll provide that in the group after today's session. Okay. So let's move forward. Okay. So starting with optics. What is optics? Optics is actually a type of electromagnetic waves. Okay. Optics is actually a type of electromagnetic waves. It is the electromagnetic wave that our eyes are sensitive of. That means there's a lot of electromagnetic waves. Okay, radio waves, heat waves, X-ray, gamma rays, and out of ultraviolet waves, infrared waves. Out of all these types of electromagnetic waves, there's one type of electromagnetic waves that are sensitive, that our eyes are sensitive, and that is optics. Okay, those are optical waves. So any feature of a electromagnetic wave, optic waves follows them. Okay, any feature in a any feature in a any feature in a electromagnetic wave, optics follow them. So you don't have to repeat all the features of electromagnetic waves. Optics follow them, like reflection, refraction, things like that. Uh, so moving forward, today we have to discuss about the properties of optics. Okay, properties of optics. So usually to draw optics, this is not visible. Yes, optics make things visible, but you can't see optics rays coming into my eye, right? It's just light. It's just light. You don't see lines coming, right? You don't see lines coming. Okay, so optics makes things visible, but optics is not visible itself. Optic doesn't, you can't see optical rays coming. So just to make it easy to represent, we decided to draw optics as lines. Okay, so to represent optical waves we use lines. So this kind of a wave we call a converging optical waves. This kind of a series we call diverging optical wave. This kind of a wave we call parallel optical wave. Okay, this kind of a wave is a parallel optical wave. Okay, there's a bunch of optical waves, optical lines like this. Okay, so in this one, what we are going to discuss mainly is the properties of optical waves, and the first property that we discuss is reflection. And reflection is quite useful. Why can you see me? Why can you see me? Because there's light coming from the bulb. That light particles reach me, that light rays reach me, they reflect from me and reach to the camera. Okay, they reflect from me and reach to the camera. That's why you see me. So that's why we can see anything. Okay, only the lights, sun, star, things that produce light, okay, things that produce light we can see directly. Everything else is a result of reflection, right? Light rays come to this pen, then reflect back to my eye. That's how I see the pen. Okay, so it's not just a bunch of lines. These reflection, refraction are quite useful stuff. Okay, they are quite useful stuff. So talking about reflection, reflection means light rays moving in a medium, light rays moving in a medium, reaching a certain surface and reaching a certain surface and return back. Okay, and return back. So this is the nature of optics. Okay, so if this is sun, it is a source of light, so it produces light, and if this is my eye, it returns to my eye. That's why I can see this one. Okay, that's why I can see this thing. Okay, so next, moving forward now, there are few like this things like reflection. Okay, things like reflection are not very random. Okay, all the reflections follow a certain series of, all the reflections follow a certain series of rules. Okay, all the reflections follows a certain series of rules. In our syllabus we learn two main rules under that. Okay, in our syllabus we follow two main rules, the first law of reflection and the second law of reflection. So talking about the first law of reflection, okay, talking about the first law of reflection, it is we analyze reflection and how it happens. We'll show the demonstrations of them. Okay, okay, We will show the demonstration, okay? We'll show the demonstration, then you will understand things better. Okay, so if a ray reach a surface like this, to make our analysis easy, we draw a perpendicular line at that point to that surface, okay? We draw a perpendicular line at that point to that surface, and it reflects back. And when it reflects, it follows a series of rules, okay? When it reflects, it follows a series of rules. What are the rules? This ray, this reflected ray, and this line, which is perpendicular, are on the same plane, okay? Everything is on the same plane, okay? Same plane. What is the meaning of this same plane? Same plane means, see, this line is on the board. See this line, it is on the board. See this perpendicular line, it is on the board, and this reflected line should be on the board. It can't come out of the board, it can't go into the board. So all three rays lies in the same plane. And the second law is, this we call the incident angle. This we call the incident angle theta. Incident angle theta. And this is the reflected angle. So I'll use the standard symbols just like in your textbook. This is I, this is I, and this is R. Clear? This is I, and this is R. Incident angle and reflected angle, I and R. So the story is, I should be equal to R. So in any reflection, the incident angle I should be equal to the reflected angle R, okay? I should be equal to R. Here. So these are the two rules of reflection, and all the reflections that happen in the world follows these rules, okay? For an example, take a mirror for an example. How can you see an image through a mirror? How can you see an image through a mirror? What is the reason? Okay, so talking about reflections, okay? Talking about a plane mirror, okay? Talking about a plane mirror, okay? If there's a source here, okay? If there's a source here, if there's a source here, it produces light. So the rules are, incident angle I is equal to the reflected angle. So if this is theta, reflected angle is theta, okay? If this is theta, reflected angle is theta, okay? So now it's one ray, and this is true for any ray, okay? So I'll draw another ray. So this ray falls like this. It falls with an angle of 0, right? It falls with an angle of 0. So definitely the reflected angle is also 0, okay? Definitely the reflected angle is also 0. Here. So these reflected rays return to my eye, okay? These reflected rays return to my eye. So this ray enters to my eye, and this ray enters to my eye. So my eye don't know the actual story. My eye don't know that rays goes in this direction, then reflects back in this direction. My eyes don't know this story. So what actually happens is, my eye thinks that these rays come in this path. My eyes think that these rays come in this path. So if I draw them back, I see the image actually here. Although the object was here, my eyes don't know the story, okay? My eyes don't know the story. Only thing that my eyes know is, okay, they comes, returns, moves like this, returns, and my eye see the world using these two rays. So what my brain do is, my brain plots these rays backwards, and it thinks that these rays were coming from here. It thinks that these rays were coming from here. That's what my brain thinks. So inside my brain, the image I see appears to be here, okay? Image I see appears to be here because based on these two rays, image should be here, okay? So if the position of the object is this, position of the image is this, and if it is actually, if this is h, this is h, okay? If this is h, this is h. So in a mirror, object distance and image distance is same, okay? I'll show you a small demonstration. Okay. Okay, so like the things we should understand is these rules, okay, these rules are not just lies or just some concepts that we developed, okay, this is what actually happens, okay. So only thing is we never see rays, okay, we just see light, okay, we never see rays, okay, we never see rays. So the problem is since we don't see the rays, okay, since we don't see the rays, we don't know that light actually appears like this. Only way to see light is using laser, okay, is using laser. So this is a laser ray and this is a normal mirror, okay, this is a normal mirror. So what happens is, see, reflection laws, see, reflection laws. Can you see this angle, okay, this angle and this angle is similar, right? These two angles are similar, see, this angle theta and this angle theta looks similar, clear? These are reflection laws and they are actually true, okay, these are reflection laws and they are actually true. And if the angle becomes 0, it returns with 0, see, if the angle is 0, it returns with 0. So these rules are actually true, okay. So if we create multiple rays, see, all the angles are equal, see, all the reflection angles are equal, okay. So that's reflection, okay, that's reflection. So moving forward, okay, okay. So lighting conditions will be, we'll be right back, okay. So because we had to transition between lights to show you the optical waves and all, it will take a small time to get it corrected. So we'll move forward, okay, we'll move forward. So the basic thing that we should understand is it's not just a lie or just a method that we create to impress you guys, okay. It's just how optics actually works, okay. It's just how optics actually works, okay. So moving forward, this is the behavior of a plane mirror, okay. This is the behavior of a plane mirror, okay. Now there are more mirrors like this, okay. There are curved mirrors too, okay. There are curved mirrors too. What are curved mirrors? What are curved mirrors? Curved mirrors are mirrors like this. Curved mirrors are mirrors like this. So reflection happens in this surface, okay? Or mirrors like this. Mirrors like this. Reflection happens in this surface, okay? These are curved mirrors, okay? Although it's curved or not, they still follow the same series of reflection laws, okay? Although they are curved or not, they still follow the same series of, they still follow a same series of laws, okay? So moving forward, okay? Moving forward, we have to learn the behavior of curved mirrors, okay? We have to learn the behavior of curved mirrors, okay? So, okay. So talking about curved mirrors, there are two types of curved mirrors, okay? There are two types of curved mirrors. What are they? What are they? What are the two types of curved mirrors? One is convex mirrors. One is convex mirrors. That means the mirror is like this. Mirror is like this. And the reflection happens in this side. And the others are concave mirrors. Others are concave mirrors. That means the mirror is like this. Reflection happens in this side. Clear? Reflection happens in this side. Okay. Now, analyzing the images and the responses of these mirrors, okay? We have to learn about few points, okay? We have to learn a few points about these mirrors. Talking about this kind of a mirror, okay? Talking about this kind of a mirror, this mirror is actually a part of a circle, okay? These mirrors are actually a part of a circle or a part of a sphere, okay? All the mirrors are part of a circle, okay? So they have a center of curvature, okay? They have a center of curvature which we call C, okay? All the mirrors have something called the center of curvature which we call C. And the center, and if we draw a line through this center of curvature, we get the principal axis. If we draw a horizontal line through this center of curvature, we get the principal axis. That is the main axis of a mirror. Main axis of a mirror. And where this main axis meet the lens, we call that the pole. We call that the pole. Okay. So now these mirrors follow the same series of rules. Okay. These mirrors follow the same series of rules. That means it's, if this is the incident angle I, this is the reflected angle R, I is equal to R and everything, it holds, okay? It holds. Based on this, we define few important points, okay? Based on this, we define few important points regarding a mirror like this, okay? Regarding a mirror like this. The most important point like that, okay? The most important point like that is the focal point, okay? The most important point is the focal point. So what is a focal point? What is the focal point? Focal point is the point at which the parallel rays, if you send some parallel rays, to a mirror, okay? If you send some parallel rays to a mirror, they will meet at a certain point. What actually happens is they follow the reflection laws, okay? Reflection laws means this is the ray, incident ray, and this may be the center of curvature. So if we draw a line between the center of curvature and this, it becomes the perpendicular line, right? So if this is a circle, okay? So if this is a circle, if this is the center of that circle, okay? If this is a circle and if this is the center of that circle, okay? If I draw a line through that center, it becomes the perpendicular line here. Why? You know these things, right? In maths, the radius is perpendicular. The line you draw between the center of a circle and the circumference, we call that the radius, and it is perpendicular to the surface. So this is the perpendicular line. So this is the incident angle theta here, right? Incident angle theta is this. That is the line between the incident ray and the perpendicular line to the surface. Okay, just like this. This is the perpendicular line to the surface. This is the incident ray. So the angle between them is theta. So here it is theta, and it should reflect back with the same angle theta. Okay, it should reflect back with the same angle theta here, and the same thing happens here. Same thing happens here. They reflect back with the same angle theta. As a result, they all meet at a certain point. Okay, as a result, they all meet at a certain point. So the point at which all the rays meet, if the rays point at which all the reflected parallel rays meet, is the focal point. Okay, this we call the focal point. Okay, this we call the focal point. Okay, that is the focal point. Okay, so now moving forward, is it clear? Is it clear up to this point? And same story. Okay, give us a minute. Give us a minute. A small change should happen to the camera. Okay, so let's move forward. Okay, let's move forward. So now, if okay, now if like we can define a focal point for concave mirrors too. Okay, we can define a focal point. Sorry, convex mirrors too. How can we define a focal point to convex mirrors? It's like this. Okay, it's like this. So this is the convex mirror, and this is the center of curvature of the convex mirror. And if a light ray falls like this, if a light ray falls like this, if we send some parallel light rays to a convex mirror like this, okay, if we send some parallel light rays to a convex mirror like this, then what happens? This is the center, this is the circumference, so this will be the perpendicular line. This will be the perpendicular line. So this is the incident angle, then it should reflect back. It should reflect back with the same angle. Okay, same thing happens here. Same kind of thing happens here. So if I draw these lines backward, if I draw these lines backward, they will meet at a certain point. They will meet at a certain point. That is the focal point of a convex mirror. Okay, that is the focal point of a convex mirror. When I send the parallel rays, they will return like this. Okay, they will return like this. But if I trace them back, they will meet at a certain point. That is the focal point. Okay, that is the focal point. Okay, that is the idea. Okay, got the idea? Is it clear? That's how we define the focal point. Okay, so this is the idea. We'll show you a demonstration too. Okay, we'll move forward a bit and we'll show you a demonstration of this too. Okay, so based on these scenarios, okay, based on these scenarios, I mean, now I know, like, I know how if I sit in front of a mirror, I know how I see myself, right? Because we know a lot about plane mirrors. Okay, We know a lot about plane mirrors, but we don't have a very good understanding. Okay, but we don't have a very good understanding about. We don't have a very good understanding about other types. Okay, what are other types? Other types is these kind of convex mirrors and concave mirrors. We don't have a very good idea. Okay, so let's try to understand how images are formed in these convex and concave mirrors. Okay, how images are formed through these convex and concave mirrors. Actually, you have seen. Okay, you have seen images of convex and concave mirrors. Any example? Any example? Side mirrors of your vehicle. Side mirrors of your vehicle. See, these are curved mirrors. Okay, they are curved mirrors. Okay, that's why you see a slightly different and slightly enlarged image through your side mirror. Okay, through the side mirror of your vehicle. Okay, so moving forward. Okay, moving forward, uh let's start with concave mirrors. So if this is the concave mirror. If a ray comes through its principal axis, if a ray comes through its principal axis, it will return through its principal axis. Okay, if a ray comes through its principal axis, it will return through its principal axis. Okay, because if the incident angle is 0, reflected angle is also equal to 0. Okay, if the incident angle is 0, reflected angle is also equal to 0. And if a parallel ray, if a parallel ray comes, okay, if a parallel ray comes to this mirror, if a parallel ray comes to this mirror, it will go through the principal, it will go through the focal point of the principal axis. Okay, it will go through the focal point of the principal axis. That is also a law, right? That's how we define the focal point. Okay, that's how we define the focal point. And if a ray goes through the focal point, if a ray goes through the focal point, it actually returns parallel. Okay, it actually returns parallel. This law is towards uh, this law is towards the end of the syllabus, but I would teach this because it makes our life easy. The reversibility of light, you have heard that, right? Reversibility of light. What is reversibility of light? Reversibility of light means if in a certain optical instrument or optical setup, if light travels in a certain path, if you send the light in the opposite direction, it will travel in the same path in opposite direction. Clear? That means if there's a lens like this, if there's a mirror like this, if there's a multiple stuff like this, if light ray goes like this, okay, as a result of multiple reflections and reflections and refractions, if the light ray goes like this, when it returns, it will return in the same path. Okay, when they return, they will return in the same path. This is reversibility of light. So it makes this much understandable. Why? If the ray is parallel, it goes through the focal point. If the ray goes through the focal point, it goes parallel, right? Okay, if the ray is parallel, it goes through the focal point, and if the ray goes through the focal point, it goes parallel. Okay, a small demonstration of reversibility of light. Okay, that's how the reversibility of light works. So moving forward, okay, moving forward, if we send a light ray through its center of curvature, it returns in the same path. Why? If it goes through the center of curvature, it falls with a 0 angle here, right? It falls with a 0 angle here. If it goes through the center of curvature, it falls with a 0 angle here. If it falls with a 0 angle here, it returns with a 0 angle. Okay, if it falls with a 0 angle, it returns with a 0 angle. Okay, එන්න බිඳුවකින් නම් යන්නෙත් බිඳුවකින් නේ. If it falls with a 0 angle, it returns with a 0 angle. Okay, so that means, okay, that means these are the basic rules. These are the basic rules of the behavior of a concave mirror. Okay, concave mirror. Based on this, okay, and if a certain another one, if a certain ray falls with the angle of theta, it returns with the same angle. That is basic reflection law. Okay, that is the most basic reflection law. If something falls with the angle theta, it returns with the angle theta. Okay, so these are the laws that decide. Okay, these are the laws that decide how an image would appear, how an image would appear in a concave lens. Okay, in a concave lens. Okay, so talking about this behavior of concave lens and how images will be formed in a concave lens. Okay, I'll do a small demonstration. I mean, I just need to like show you that these things are actually true. Okay, so see, if a ray goes like this, if a ray goes like this, it returns in the same path. Okay, and if a ray goes like this, see, till if a ray falls like this, see, if this is theta, this is theta. If ray falls with a zero angle, it returns with a zero angle. Okay, it returns with a zero angle. And can you remember that we defined? Can you remember that we defined something called the focal point? That focal point is something like this. See, all the rays should meet at the certain point. All the rays should meet at a certain point. All the parallel rays should meet at a certain point. See, all the parallel rays should, if you send 3 parallel rays, okay, all of them would meet at the same point. That is the focal point that we discussed. Okay, and if somehow if we send a ray through that focal point, okay, these things should be perfect, so it's not, you cannot be demonstrated perfectly. Okay, if something goes through this focal point, it will go parallelly. Okay, see, so this is a parallel ray, this is a parallel ray, it goes through the focal point, it goes through the focal point. If I send a ray through that focal point, if I send a ray through that focal point, it returns parallelly. See, okay, if a ray is parallel, it goes through this focal point. This is the focal point. Okay, this is the focal point, this one is the focal point. And if I send a ray through that focal point, if I send a through that focal point, it returns parallelly. Clear? It returns parallelly. Okay, and at the same time, see, if a ray goes like this, it returns in the same line. Why? This should be the center of curvature. This should be the center of curvature. Okay, if a ray goes like this, it returns in the same path if it goes through the center of curvature. So this should be the center of curvature. Okay, so those are the rules, right? If it goes through the center of curvature, it returns through the center of curvature. If it falls with zero angle like this, it returns in the same path. If it falls with angle theta, it returns with angle theta. If a ray is parallel, it goes through if a ray is parallel, it goes through the focal point. If you send the ray through the focal point, if you send the ray through the focal point, it returns parallelly. It returns parallelly. So that's how it actually works. Okay, that means these rules are not actual fascinations or not actual imaginary stuff that we define. This is how actually optical rays work. In our day-to-day life, we don't see that because only when we use laser. Okay, in our day-to-day life, we don't see that because only when we use laser, we see the actual behavior of light. Okay, only when we use laser, we see light as rays. Otherwise, we don't see light as rays. Now you don't see this light coming towards me and moving towards the camera as rays, right? You just see light. Only when we use laser, we see light as rays. Clear? Got the idea? Got the idea? Okay. So based on these rules, we can see how a concave mirror forms images. Okay. Based on this, we can see how a concave mirror forms images. Okay. So, see, if we place, okay, if we place, focus here, if we place an object, if we place an object in between the lens and the focal point, okay, if we place an object in between the lens and the focal point, okay, see, from this subject, okay, from this subject, I'll draw the rays that I know how to draw. I'll draw the rays that I know how to draw. How? I'll draw a parallel ray. See, this is the parallel ray. A parallel ray will return through the focal point. A parallel ray will return through the focal point. And I'll draw a line such that it goes through the center of curvature. It will return through the same line, same center of curvature. Then this is my eye. These rays enter to my eye. When my eye trace these rays back, they gets collected here. Clear? They gets collected here. That means the actual image is formed here. Clear? That means the actual image is formed here. That means when they give me an object and ask me to draw the image of that, what I do is I draw the rays that I usually know how to draw. What are the rays that I usually know how to draw? Focus. A ray that is parallel. A ray that is parallel. It goes like this and it goes through the focal point. A ray that goes through the I'll draw a ray that goes through the center of curvature. A ray that goes through the center of curvature will return through the center of curvature. These two rays which return will enter to my eye. Then my eye will trace these images back, these rays back. Then they will meet here. So my eye will assume that the image is here. This is a virtual image. Virtual image means that image is not actually there, okay? Virtual image is that image is not actually there. It just appears to be there, okay? It just appears to be there. That means that's how my eye see this, okay? That's how my eye see this. It just appears to be there. So we call an image which is not actually there, that appears to be there, we call it a virtual image. It is a virtual image. Then the next one, what happens if we place an object on the focal point? What happens if we place an object on the focal point? See, I'll draw the rays that I know how to draw. What are the rays? I'll draw a parallel ray. I'll draw a ray that is parallel. What happens to a parallel ray? It goes through the focal point. It goes through the focal point. Clear? Then if a ray goes like this, I'll draw another ray through the center of curvature. I'll draw another ray through the center of curvature. It will return to go through the center of curvature back. Clear? It will return to go through the center of curvature again. In this case, these two rays appears to be parallel. See? In this case, these two rays appears to be parallel. That means they will never meet. They will never meet. That means the actual image will be formed at infinity. They will never meet in this scenario. Clear? The ray goes like this and goes through the focal point. I just draw the rays that I usually know how to draw. What are the two rays that I usually know how to draw? I know how to draw the path of a parallel ray. A parallel ray will go through the focal point. So I'll draw a parallel ray from this head and it will go through the focal point. And I know how to draw a ray that goes through the center of curvature. If a ray goes like this, if a ray goes through the center of curvature like this, it will return back through the center of curvature. Clear? If a ray goes through the center of curvature, it will return through the center of curvature. So if this ray goes like this and if this ray returns like this, they will enter my eyes like this. They will enter my eyes like this, and my eyes will trace it back. Since they are parallel, my eyes will never see where they meet. So in this case, what actually happens is, if an image forms, it will actually form at infinity. Clear? If an image forms, it will actually form at infinity. It will never meet. Clear? It will never meet. Okay? Then the next example. Bring it here. The next example. Now, if I place the object between the focal point and the center of curvature, I'll draw the two lines that I usually know how to draw. What are the two lines? If a parallel ray emits from this head, it will go through the focal point. And if I draw a ray that goes through the center of curvature like this, it will return through the center of curvature. Now in this case, these rays goes like this, and they actually meet here, okay? And they actually meet here. This parallel ray returns through the focal point like this, and this ray goes and returns to the center of curvature, and they actually meets here, right? They actually meets here. If the rays actually meet there and actual image is formed there, we call that kind of image a real image. Clear? If rays actually goes, they actually meet here, then we call this a real image. Clear? This is what? This is a real image. Okay? An image that is actually there. Then the image my eyes see is actually there. In these examples, okay? In these examples, this and this, the image is not actually there. When my brain trace back, they meet here. So they just appears to be there from my eyes. They are not actually there. But in this case, these two rays which follow the reflection laws actually meet here. So it creates a larger image than the object. It creates a larger real upside down image of the object. It creates a larger real and upside down image of the object when the object is between the focal point and the center of curvature. Then when the object is on the center of curvature, what happens? When the object is on the center of curvature, I'll draw what I know how to draw. A parallel ray. What happens to a parallel ray? A parallel ray will go through the focal point. Okay. Then for this example, I'll draw another ray that I know how to draw. What is that? Just like in previous examples, I can't draw the ray that goes through the center of curvature because the object is actually on the center of curvature. So I will draw a ray that goes through the focal point. A ray that goes through the focal point will return parallelly, right? A ray that goes through the focal point, as I explained before, will return parallelly, then they will meet here. That means the image of this object will be formed here. So image will be formed at the same place. Image and the object is equal in size, and image is upside down to the object. Okay? And image is upside down to the object. Here. So this is the story. This is how the image is formed if you place the object on the center of curvature. Okay, let's move forward. The last one. What happens if you place the object away from the center of curvature? I'll draw what I know how to draw. I'll draw the parallel ray. I know that the parallel ray will return through the focal point. Okay. Okay, so it will go like this. And I'll draw the ray that goes through the center of curvature. It will return in the same path. We know that if a ray goes through the center of curvature, it returns through the same path, and these two rays will meet here. Okay, these two rays will meet here, and this will be the image. Okay, and this will be the image. Clear? So it is a much smaller image which is upside down. Okay, a much smaller image which is upside down, but actual rays meet here, so this is a real image. So you may ask, why do I draw two rays? Because I can find the position only by two rays. Because I know the position when two rays cross, I know that this is the position of the image. And why do I always draw the same two rays? Because that's all I know how to draw. What actually happens is all the rays travel in a way that they create this image. Okay, that means all the rays, in the sense, focus here, all the rays in the sense, if a ray goes like this, a very random ray goes like this, it will also return in a way that it creates the image here. Okay, it will also return in a way that it creates the image here. A very random ray like this, it will also return in a way that it creates the image here. Okay, so all the rays, okay, all the rays move in a way, all the rays move in a way, all the rays move in a way that image is created here. Okay, in this example also, focus here, even the other rays, okay, even the other rays, a very random ray like this, a very random ray like this, it will also go in a way that it creates the image here. A very random ray like this, a very random ray like this, it will also go in a way that it creates the image here. So actually all the rays goes in a way that it creates the image here. But why don't I draw all the rays? Okay, why don't I draw all the rays? Because I don't know how to draw all the rays. I only know how to draw two rays. What are these two rays? I only know what will happen if a ray goes parallelly. If a ray goes parallelly, it goes through the focal point. So from this head, I draw a parallel ray, so it will go through the focal point. And what is the other ray? I exactly know the behavior of. I know if I draw a ray through the center of curvature, it will return through the center of curvature. So I exactly know the path of these two black rays that I draw. That's why I always choose to draw those two rays. It makes my life easy because I'm working with two rays that I exactly know the behavior of. Clear? Got the idea? That's why I always choose to draw those two rays. Is it clear, everyone? Is it clear? Reply, everyone. Nice. 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 So yes, there are some questions about wave particle duality uh, and optics behaving as particles. It's actually quantum mechanics. You have a lesson like that in A-level science. There's a lesson called matter and radiation in A-level science. I could teach you everything because it would cost a lot of time, which is not useful for O levels. So I would keep that. But if you like to learn more than that, you have the option of there's a lesson called matter and radiation in our YouTube channel. It is an A-level lesson. If you like, you can follow that. Okay. If you like, you can follow that. Here. So that is the story. Because I'm not going to talk about wave and particle duality and waves behaving as particles. Okay, it's a different story, but it's a nice domain of physics. It's Einstein physics. We don't have that time now, but if you like, I can teach it later. Okay, and anyways, if you're doing science for A levels, you will definitely learn this kind of stuff. Okay, so I recommend you doing science for A levels, everyone. Okay, I mean the actual O level science is quite boring. They just tell a bunch of stuff. They never tells how it actually happens. They never shows how it actually happens. You just learn facts. So what actually happens is you are learning science in a way, science like it is history. Okay, you are learning science as facts. No, science is meant to learn as applications and as questions and answers. You ask a question about nature and you get an answer about that behavior of nature. That is physics. Okay, so the way you learn physics and science in the O-level syllabus, that's what actually make you hate science. Okay, actual science is not boring like that. It's about how things happen, why things happen, and how they are applied and how they actually looks like. Okay, it's quite interesting science. Okay, let's move forward. Okay, let's move forward. Okay, moving forward. Moving forward. What about convex mirrors? It's quite simple. Okay, convex mirrors holds the same series of rules. Okay, convex mirrors holds the same series of rules. What are they? What are they? If a ray, if a ray moves through the principal axis, it returns through the principal axis. If a ray falls with an angle theta, it returns with angle theta. If a ray falls parallelly, if a ray falls parallelly, it returns like this. It returns like this. Parallel rays returns like this. Parallel rays return in a way that they meet at the focal point. Parallel rays return like they meet at the focal point. That means this is parallel, and this is parallel. They return back such that they meet at this point. Clear? This parallel ray, and this parallel ray returns back such that it meets at this point, which is the focal point. Clear? Parallel rays return in a way that they meet at the focal point. They meet at the focal point. Then again, if a ray moves towards the center of curvature, if a ray moves towards the center of curvature, if a ray moves towards the center of curvature, it returns in the same path. Clear? If a ray returns, if a ray moves through the center of curvature, that means if a ray comes towards the center of curvature, it returns in the same path. Clear? It returns in the same path. Okay, so that is the story. Okay, that is the story. These are the rules. Okay, these are the rules that we should follow. So I'll show you like that's actually true. Okay, That's actually true. How it works is actually true. So how it actually works is, see, if a ray goes in the main axis, it returns in the main axis. If it falls with an angle of theta, if it falls with an angle of theta, it returns with angle theta. If it falls with angle theta, it returns with angle theta. Clear? And at the same time, if a ray is parallel, it returns in a way that it meets at the focal point. I can show you. This focal point is not actually there, okay? This focal point is not actually there. Why? See, the rays go like this, okay? Rays go like this. Rays go in this path, and this path, okay? Rays go like this. And this ray returns in the same path. This ray returns in the same path. This ray returns in this path. This ray returns in this path. This ray returns in this path. And this ray returns in this path. So their focal point is not actually there. To find their focal point, I should trace these lines back. To find their actual focal point, I should trace these lines back. See? I should trace these lines back. See? I should trace these lines back. This line, I'm gonna trace him back. When I trace them back, they meet at a certain point. This is the actual location of the focal point. This is the meaning of something imaginary. Something imaginary means these are the rays that enters my eyes. So based on these rays, I think that these rays are coming from here. Clear? That is what we call something imaginary. That's not actually there. These are the actual rays. These are the actual rays. But if I plot these rays back, they will meet at a point, and that's what I call the focal point. Okay, that's the meaning of this. Okay, let's return to the lesson. There's a multiple questions, not actually multiple. There's a lot of questions. I'll see them. Okay, regarding A levels and all. Yes, A level science is not actually quite complex. It's like it's just interesting. Okay, it's just interesting. Okay, how old is me? Like I think 25. Yes, as I remember 25. What is my O level result? What is my A level result? It should be obvious, right? You can't end up at University of Morocco with weak results. Okay. Okay. Let's move forward. So based on this, okay, if we draw how an image is formed, okay, based on this, if we draw how an image is formed in a convex lens, okay, if we draw how an image is formed in a convex lens based on this, okay, how an image is formed in a convex lens, what actually happens is, for whatever the object, it's the same story. I draw what I know how to draw. What are the things I know how to draw? This is the object, this is the convex lens. I will draw a parallel ray. If I draw a parallel ray, what happens? It returns such that it will go through the focal point, right? A parallel ray will return such that it will go through the focal point. Clear? A parallel ray will return such that it will go through the focal point. And if I draw a ray such that, it goes through the center of curvature. It goes through the center of curvature. It will return in the same path. So based on these two returning rays, the object should be formed here, right? Object should be formed here. Here. Got the idea? Object should be formed here. Based on these rays, object should be actually formed here. So whatever the object, image will be formed. A smaller image that is virtual will be formed, okay? A small image that is virtual will be formed. So if I draw it alone to give you a nice idea, so this is the lens, this is the main axis. I just place an object like this. Then I draw what I know how to draw. What are the rays that I know how to draw? I know that if a ray goes parallelly, it will return in a way that I know if a ray goes parallelly, it will return in a way that it goes through the focal point. Then the next one is if I draw a ray such that it goes through the center of curvature, it will return in the same path. So these returning rays, this one and this one, they will never meet in this side, right? These returning rays, this one and this one, they will never meet in this side. They will only meet here. Focus here. They will only meet here. Here. They will only meet here. Here. That means the image will be actually formed here. Clear? Image will be actually formed here. They will actually meet here and the image will be actually formed here. Clear? That's the story. Okay? That's the story. So that's the story about mirrors. Okay? That's the story about mirrors, and the summaries and all about these mirrors are provided in the short notebook. Okay? Everything is provided in the short notebook. Okay? Yes, we always start drawing the rays that we know how to draw. Okay? Clear? A-level science means maths, biology, both. Okay? If you do maths or if you do bio, whatever you do, okay, you end up doing physics. Okay? Whatever you do, maths or bio, if you're going to be a doctor or an engineer or whatever the science stream you choose, you end up doing physics. Okay? Is it clear, everyone? Is it clear? Any questions up to this point? Okay. Let's move forward. Okay. Next one. This is how we use lenses. Okay? This is how we use lenses to manipulate light. Okay? That's how we use lenses to manipulate light. So moving forward from this, okay, moving forward from this, the next main concept about light is refraction. Okay, next main rule about light is refraction. What is refraction? Reflection is light going, hitting a wall, return into the same medium. Okay, it's light moving, hitting a wall, return to the same medium. It's return into the same medium. Then what is refraction? What is refraction? Refraction is light reaching a certain light reaching a certain barrier, light reaching a certain barrier, and it falls to the other side of that barrier. It does not return to the same side. It falls to the other side of the barrier. It falls to the other side of the barrier. This is refraction. And when this happens, the light ray bends. Okay, light ray bends. The actual reason for that is the velocity of the light changes. Okay, actual reason is the velocity of the light changes. Due to this change in velocity, okay, due to this change in velocity, it bends a bit. So when this refraction happens, it also follows two main rules. Okay, one is when a refraction happens. Okay, when a refraction happens, it falls here, it falls here, and it falls to the other side. Okay, and it falls to the other side. And in this case, okay, and in this scenario, this is the incident ray, that falls to the boundary. Then to make it easy, to make the drawings easy, I draw a perpendicular line. I draw a perpendicular line to the surface. And then another ray, this is the ray that falls to the other side. This is the ray that falls to the other side. Now, this incident ray, the refracted ray, and this perpendicular ray should be in the same plane. That means if it goes in this plane, it can't come out of the board, it can't go into the board, it should be on the board. So everything should be in the same plane. Clear? Everything should be in the same plane. Okay. And the other rule is this is the incident angle I. This is the incident angle I. This is the refracted angle R. The sine I and sine R holds a relationship. The sine I and sine R holds a relationship. That is sine I over sine R is a constant. Sine I and sine R is a constant. That means for a given two medium, this sine I over sine R ratio is a constant, and we call this Snell law. And the actual ratio between this sine I and sine R we call the refractive index between these two medium. Okay, it's the refractive index between these two medium. Clear? That is the refractive index, a new term. It is a property of these two materials. Okay, it's a property of these two materials. Based on this property, okay, based on this property, we give two names to these two sides. One side is denser medium and one side is the rarer medium. So denser medium is the side where this optic ray's velocity is low. Okay. Denser medium is the side. Denser medium is the side where that. So based on this, okay, based on this, the two sides we divide as denser medium and rarer medium. Okay. Yeah. So that what is the denser medium? Okay. Yeah. What is the denser medium? What is these two medium? Where is the highest velocity? Yeah. I'll explain that. Okay. There are a few questions. I'll explain that. So what is the denser medium? In the denser medium, light ray travels a bit slowly. Okay. In the denser medium, light ray travels a bit slowly, and in the rarer medium, light ray travels faster. Okay. In the rarer medium, light ray travels faster. So what actually happens is, if a light ray goes from a denser medium to rarer medium, here light ray goes slowly, here light ray goes faster. In that case, if it goes from a denser medium to rarer medium, it will fall out. That means it will go like this and it will fall out. It will go away from this perpendicular line. And if a ray goes from the rarer medium to denser medium, if a ray goes from the rarer medium to denser medium, it will move towards, it will move towards the perpendicular line. It will move towards the perpendicular line. Okay. So denser to rarer, it moves away from the perpendicular line. Rarer to denser, it will move towards the perpendicular line. Okay. That's the behavior. Okay. And we can call the denser medium as the site with the higher refractive index. Okay. Denser medium has the denser medium is the site with the higher refractive index. That means in the side of the denser medium, the refractive index is higher, and in the rarer medium, the refractive index is lower. And talking about velocities on the side of the denser medium, velocity is smaller than on the side of the rarer medium. So in the rarer medium, velocity is higher. In the denser medium, velocity is lower. For an example for light, if light goes through air, in air light moves faster, and if it moves into glass, in glass it moves slowly. So fast means this is the rarer medium. Slow means this is the denser medium. So air is the rarer medium, glass is the denser medium. So going from rarer medium to denser medium, it should move towards the perpendicular line. Okay. It should move towards the perpendicular line in this case. Clear? That means the light ray should bend towards the perpendicular line. Okay. So that's the story. That's the story. And when something like this, and again, if it goes from glass to air, what happens? If it goes from glass to air, what happens? So if it goes from glass to air, in glass it is slow, in air it is fast. That means glass is the denser medium, air is the rarer medium. Going from the denser medium to rarer medium, angle increases. Okay. So that's how it looks when we are going from denser medium to rarer medium. And at the same time, a special scenario could happen. Okay. Special scenario could happen when we are going from a denser medium to rarer medium. What is that? A special scenario could happen when we go from a denser medium to rarer medium. That is, if we go like this, from denser medium to rarer, it will move away. Then if I increase this angle a bit, focus here. If I increase this angle a bit, it will move further away. If I keep increasing this angle, it will keep moving further away. And at a certain point, at a certain angle, it will move through this line. It will move through this line at a certain angle. And if I exceed that angle, it will return back to the same medium, showing a reflection. So where this incident starts happening, That means when this ray goes through these surfaces, the angle of incident at that point, I call that the critical angle. That is the critical angle. So this is the critical angle. If it falls with the critical angle, it goes through the surfaces, and if you exceed the critical angle, it will return back to the same medium. This scenario we call total internal reflection. Okay, this scenario we call total internal reflection. Okay, that means it returns to the same medium. Okay, it returns to the same medium. It returns to the same medium. Okay, so that is the idea. That is the idea. Okay, so there's a lot of benefits of this total internal reflection. One is fiber optics. Okay, fiber optics. Fiber optics cables uses total internal reflection. That means it sends signal. It sends signal like this, and using total internal reflection, it goes through the fiber optic line. Using total internal reflection, it goes through the fiber optic line, and this way light can travel for kilometers without losing much of energy. Okay, light can travel for kilometers without losing much energy. So it starts here, ends at kilometers away. Sometimes information travel continents through these fiber optic cables. Okay, sometimes information travels through continents. Okay, thousands of kilometers. Okay, light travels through thousands of kilometers. Clear? So that is the idea. Then, then what are the other applications? There's a lot of applications the same way. Like, have you seen like submarines? All submarines, this setup where all the submarines, they look what is above the water using systems like this. They use somewhat a total internal reflection. How? This system is made like this. This system is made like this. There's a small prism like this. Then what happens? Light ray goes like this. A total internal reflection happens here and falls here. Okay. Then the same scenario could happen here. Same scenario could happen here. It's like this, then like this, then it falls here, then returns in this path here. So light ray falls here, reflects here, falls here, reflects here, and goes in this path. Okay, like that, whatever happens here, that information passes through until this point. Clear? Whatever happens here, that information passes until this point. Clear? That is total internal reflection. Clear? That is total internal reflection. Okay, so moving forward, we still haven't discussed the most useful benefit of refraction. What is that? The most useful use of refraction is lenses. See them, lenses. Okay, that's how many of the people see the world now. Okay, reply who's wearing lenses. The people who wear lenses. Actually, wearing lenses is considered to be a property of evolution. That means your DNA is much improved if you can't see the world. That means in the future everyone's gonna wear lenses. That means we are going towards that. So if you are using lenses now, that means you have evolved a bit more. Okay, be happy about that. Just kidding. So moving forward, moving forward. Someone asked for the reason for this change in velocity. Someone asked for the reason for this change in velocity. I mean, the main reason for this change in velocity is different materials support different waves differently, right? That means optics can freely move in this air. But this optic wave find it very difficult to go through this wall to other side, right? So when you have a light here, light will not appear in the other side. Why? This light find it very difficult to go through the wall. That means the wall doesn't allow the light to travel easily, which means it makes the light slow. Okay, so that's why the velocities are different in different materials. Okay, talking about the lenses. Okay, there are different types of lenses, and we discuss about four main types of lens. Yes, we initially discussed about four main types of lenses, but it boils down into two main types of lenses. Okay, so like I'll directly discuss about the main two types of lenses. They are convex and concave. Convex lens is a lens that looks like this. Okay, and these lens two sides are actually made out of two circles like this. Okay, two sides of the lens is actually made out of two circles like this, and this is we call a concave lens. This we call a concave lens, and it is also made out of two circular sides like this. Okay, it's also made out of two circular sides like this. Then if a ray, this kind of lens we call converging lens. That means if a ray falls on them, they converge them. They tend to converge them. Okay, they converge, collect the ray into a single point. And these kind of lens we call them diverging lens, because if a ray falls onto them, they diverge. Okay, all of this is a result of refraction. Okay, all of this is a result of refraction. Okay, then just like before talking about these lenses, okay, these convex lenses and concave lenses have few special points. Okay, so this is the center of curvature of this circle. That means that is the center of curvature of this lens. This is the center of curvature of this side. And when I draw a line between them, this we call the principal axis of that lens. This we call the principal axis of this lens, and the exact center of it, that means in the lens, the point that is situated in the lens, we call this the optical center. We call this point the optical center. Okay, this is the optical center. Okay, then there's another special point, and same story here. Okay, same story here. That means this is the center of curvature of this side. This is the center of curvature of this side. Okay, then if I draw a line between these two center of curvatures, that is the principal axis, then the exact point on the lens on that line, we call that the optical center. We call this the optical center. And at the same time, there's a special point in these lenses just like before, that is the focal point. We define the focal point such that if we send a series of parallel rays towards the lens, they will meet at a certain point. They will meet at a certain point. We call that the focal point. Clear? If we send a series of parallel rays towards the lens, they will meet at a certain point. We call that the focal point. And for a concave lens, if if I send a series of parallel rays to a concave lens, they will diverge, but they will diverge in a way that they meet at the same point on the principal axis. They diverge in a way that they meet at the same point on the principal axis. This point we call the focal point of this concave lens. Clear? So this is the focal point of this convex lens. This is the focal point of this concave lens. Clear? So that's the story. Okay, that's the story. So again we can analyze. Again we can analyze how images are formed through these lenses. Okay. For that we have to learn a few rules related to these lenses. Okay. So let's start with convex lens. Okay. Let's start with convex lens. Okay. So what are the rules regarding a convex lens? What are the rules regarding a convex lens? Rules regarding a convex lens is if a ray goes like this through an optical center, it will go in a straight path. If a ray goes like this through its optical center, it will still go in a straight path. Okay, if any ray goes through its optical center, they will go in a straight path. Okay, they will go in a straight path. And if we send a parallel ray to the principal axis, if we send a parallel ray to the principal axis, they will go through what? They will go through the focal point. Okay, they will go through the focal point. Using these two main fundamentals, okay, using these two main fundamentals, we can see how images are formed through a convex lens. Okay, how images are formed through a convex lens. I have to show you the demonstration, but I'll show you the demonstration with this and that. I have to show you two demonstrations, so I'll show you the both demonstrations. Okay, I'll show you the both demonstrations. Okay, I'll show you the both demonstrations at the same time. Okay, so here let's start with this. Okay, I'll explain you with the practical example, then you will understand things better. But before that, I'll finish a bunch of content and go for the demonstrations. Okay, otherwise it consumes a bit of time. So again, let's assume that if we place an object between the lens and the optical and the focal point in this side, then what happens? If I place an object like this, now I need to find the position of the image of this guy. I can find the position of the image of this guy by drawing the lines that I already know how to draw. One is the ray that goes through the exact center. One is the ray that goes through the exact center, which is the optical center. So it goes directly. Then if I draw a parallel ray, like this, what happens? A parallel ray like this will go through the focal point. Then these two rays will never meet in this side. But when they enter into my eye will trace them back. And my eye will imagine that there's an image here. Okay. My brain and eye together will imagine that there's an image here. So these are not rays that actually meet. These are rays that appears to meet here. That's what we call an virtual image. Okay. That's why we call a virtual image a bunch of rays that never meet actually, but they appears to meet here in my eye. Okay, so virtual images are a result of how my eyes see the world, how my eyes perceive the world. Okay. So the next one, this one. What happens if I place it on the focal point? What happens if I place an object on the focal point? I'll draw what I know how to draw. A ray would go through the optical center. It will never bend. And the ray that goes parallel, it will go through the focal point. And these rays will enter my eye. But in my eyes, when my eye traces them back, they never meet. They are parallel. So they will meet in the infinity. That means they will actually never meet. They will actually never meet. Okay. They will meet in the infinity and they will actually never meet. Okay. So in my eyes, I will never see your image. Okay. In my eyes, I will never see your image. It will be formed at infinity. So when you place the object on the focal point, the image will be formed at infinity and you will not actually see them, or you will see them far away. Okay. You will see them far away. Then what happens if I place my object between 2f and f? Okay. What happens if I place my object between 2f and f? Okay. What happens? If I place my object between 2f and f, what happens is I'll draw what I know how to draw. A ray that goes through the optical center goes in a straight line through the optical center. A ray that goes parallel, it will go through the focal point. Then they will meet. They will actually meet, okay? Here they will actually meet. Ray will actually meet at a position away from the 2f. So it will appear to be larger than this one. It will appear to be larger than this one. Here. So the story is, if I place an object between 2f and f, the image will be larger, but it will be real because the actual rays meet here, okay? The actual rays meet here. So this will actually be a real image, okay? This will actually be a real image. A real image will be formed, okay? A real image will be formed which is larger than the object, okay? Which is larger than the object. Then what if I place the object on, so this is when I place the object between the lens and the f. It's a virtual large image. When I place the object on f, it is an image formed at infinity. When I place the object between 2f and f, an image will be formed away from 2f. It will be upside down. It will be larger, but it will be real, okay? It will be real. Real rays meet here, okay? Real rays meet here. Then what if I place the object at 2f? What if I place the object at 2f? If I place the object at 2f, I'll draw what I know how to draw. The ray will go like this, and this ray will be parallel. This ray will be parallel. Then we'll go through the focal point. Then it will go through the focal point. Then what happens? The ray that goes through the optic center, it goes in a straight line. The ray that is parallel to the principal axis goes through the focal point. Then they will meet here exactly at 2f, and the size of this one and this one becomes exactly similar. Size of this one and this one becomes exactly similar. Okay, so if you place the object at 2f, image will be formed at 2f. Clear? If you place an object on 2f, the image will be formed in 2f. It will be a real upside down image. It will be a real upside down image which is equal to the size. Okay. Then what if I place the object away from 2f? I'll draw what I know how to draw. The ray that goes through the optic center, it continues in the same path. The ray that goes through the optic center, it continues to the same path. Okay, it continues to the same path here. Then the ray that goes parallel to the principal axis goes to the focal point. Then they meet at a point here which creates a very small image between f and 2f. That means if I place the object away from 2f, the rays will meet between f and 2f. It will create an upside down real image, but it will be really smaller than the object. It will be really smaller than the object. Then what happens? Okay, clear? So let's move to the demonstration of this and how it actually happens. Okay, see this? See this? See? If a ray, see, let's first see the focal point. Okay. See, if a bunch of parallel rays comes to a convex lens. See what happens? They meet at a certain point. They meet at a certain point. So this is the focal point. This is the focal point. Okay. Now see, if a ray comes parallel to the principal axis, this is the principal axis. If a ray comes parallel to the principal axis, it will go through the focal point. It will go through the focal point. Now see, if a ray goes through the, now see what happens if a ray goes through the optic center. Optic center means the exact middle. What happens if a ray goes through the optic center? See, it goes in a straight path. See, it goes in a straight path. See, it goes in a straight path. It goes like this. It goes in a straight path. Clear? So these are the rules. Okay, these are the rules. Okay, parallel rays goes through the focal point. Ray that goes through the optic center continues without bending. It continues without bending. It continues without bending. Same story with the concave lens. Okay, same story with the concave lens. Okay, so what happens is, see, if rays go like this, if rays go like this, these rays will go like this, and this. But if I trace them back, if I trace them back, if I trace these rays back, they will meet at a certain point. That's what we call the focal point of the concave lens. Okay, if you trace these rays back, they will meet at a certain point. That's what we call the focal point of the concave lens. Then again talking about the concave lens. Okay, again talking about the concave lens, a parallel ray will go in a way, a parallel ray will go in a way that it meets at the focal point. It meets at the focal point. Clear? A parallel ray, this is a parallel ray, goes in a way that it meets at the focal point. It goes through the focal point. Clear? And again for this one also, this part I haven't explained it. I'll explain it because I could quickly finish stuff this way. That's why I'm explaining the concave lens too. So the rules about a concave lens is a parallel ray will go out in a way that, just like in a way that when I trace that back, it will meet at the focal point. Clear? That means if I try to explain it again, okay, if I try to explain it again, this is a parallel ray. This is parallel to the principal axis. This is parallel to the principal axis. So a parallel ray will go in a way that if I trace it back, it goes through the focal point. Clear? It goes through the focal point. And if I send a ray through the optic center means the exact center of a concave lens. If I send a ray through the optic center means the exact center of the concave lens, it will go in a straight path. See, it will not bend, and it will go in a straight path like this. Clear? It will go in a straight path like this. Okay, so talking about the images of concave lenses. Okay, talking about the images of convex lenses. Okay, so this is actually a convex lens. This is actually a convex lens. This is actually a convex lens. This is a mirror. Sorry, this is the object. Okay, this is the object. We use this as the object. Then this is the lens. This is the lens, and this is where the image will be formed. Okay, so you should see now this is the object. Okay, Now this is the object. Okay. So see, if the object and the if the object is very close, if the object is very close to the lens, if the object is very close to the lens, when the object and lens is very close to each other, image is larger. Image is larger. Can you see that example? Can you see that example? Go to this one. In this line, one, two, third one, third one, third one, this one, here, this one. Okay. This one. When the object is between f and 2f, not that. Yeah, the one above. That one. Yeah. So when the object is between f and 2f, when the object is between f and 2f, it creates a larger image. Can you see? It creates a larger image. Now go to this one. Go to this one. Second one in this row. Second one in this row. Yes, that one. See, in that case, when the object is away from 2f, when the object is away from 2f, it creates a very small image. Okay. It creates a very small image. Now see here. Now this is the object. This is the lens. If I move the lens away, when the distance is large, see, it creates a very small image here. See, it creates a very small image here, which is upside down. This is actually a F, okay? Object is a F. So the image is upside down, clear? The image is upside down, clear? Image is real, and the image is upside down, okay? And the image is upside down. If I move this very close to, the object, if the object and the mirror is really close, it will create a large image. It will create a large image. If the distance between the mirror, and the object is very large, it will create a very small image here, clear? It will create a very small image here, okay? So that's how it behaves, okay? That's the behavior of it, okay? Now, what about the images of a concave lens? So that's about the images of a convex lens, okay? That's about the images of a convex lens, okay? Then let's quickly draw the images of a concave lens. That is really easy, okay? That is really easy. See, again explaining, I was talking about this image. See, when the object and mirror is very close, it creates a large image. When the object and mirror is far away, it creates a much smaller image. That's what you saw, okay? That's what you saw as a larger image and a smaller image, clear? That's what you saw as a larger image and a smaller image, clear? Then, talking about the images of a concave lens, it's quite simple. Why? These are the rules that I explained. If this is a concave lens, okay? If this is a concave lens, if a ray goes parallel to the principal axis, of a concave lens, it goes away such that when I trace it back, it meets at the focal point, clear? If a ray goes like this, parallel to the principal axis, okay? If a ray goes like this, parallel to the principal axis, okay? If a ray goes parallel to the principal axis, okay? If a ray goes parallel to the principal axis, it will go away in a way that it meet at the focal point. And if a ray goes through the principal axis or the optical center, sorry, if a ray goes through the optical center, it continues to go through the optical center. These are the two rules of a concave lens, okay? If a ray goes parallel to the principal axis, it will go away. It will go away such that it meet at the focal point. If a ray goes through the principal axis, it will move through the principal axis forever. It will not bend. So based on this, okay, based on this, we can show how images formed in a concave lens. It's quite simple. Why? Why is that simple? Why is that simple? Whatever the location of the object, all I know is how to draw through two lines. One is the line that is parallel to the principal axis. One is the line that is parallel to the principal axis. This line will go in a way that it returns to the focal point. That means whatever the line that is parallel, it will go in a way that when I trace it back, it meet at the focal point. And if a ray goes through the optical center, it will just continue. Now see, where do these lines meet? Focus here. Now see, where do these lines meet? These lines meet here, right? These lines meet here. That means the image is formed here and it is not an actual image. Why? This line is not an actual line. It goes in this direction, okay? This line goes in this direction. This line goes in this direction. They never actually meet. These two lines never actually meet. But when I trace them back, they appears to meet here. So when these rays enter to my eye thinks that the image will be formed here. So this is actually an upright virtual image that is really small. Okay, this is actually a upright virtual image that is really small. Clear? Upright virtual image that is really small. Okay, so that is the behavior of concave lens, and whatever the object, concave lens will form a similar image. Okay, concave lens will form a similar image whatever the object is. Okay, so there was a question like about a small demonstration. I'll return to the demonstration again. Okay, so this is the story, okay, about the rules. See, this is the focal point. See, parallel rays meet at the focal point. See, parallel rays meet at the focal point. So this is the focal point. Clear? Parallel rays meet at the focal point. This is the focal point. So if a ray goes parallel to the principal axis, it goes through the focal point. That is the idea, okay? If a ray goes parallel to the principal axis, it goes through the focal point. Okay? Then, if a ray goes through the principal axis, through the optic center means the exact center of the lens. If a ray goes through the exact center of the lens, it goes in a straight path. These are the two rules of a convex lens, okay? If it is parallel, it goes through the focal point. If it goes through the optic center, it just continues, okay? Then about a concave lens, it's the opposite story. That means its rays go like this, okay? Its rays go like this. 3 parallel rays. And now when I trace them back, when I trace these rays back, they meet at a certain point. What is that point? That is the focal point of this concave lens. So the rule is, if a ray goes parallel to the principal axis, if a ray goes parallel to the principal axis, okay, it appears to be going through the focal point. That means if I trace this back, it goes through the focal point. If this ray, if I trace it back, it goes through the focal point. And if a ray goes through the optic center, if a ray goes through the optic center, if a ray falls to the optic center, that means the exact center of a concave lens, okay? If a ray falls to the exact center of a concave lens, it goes in a straight path, okay? It goes in a straight path. Based on these two rules, we explain everything, okay? Based on these two rules, we explain everything. Here, that's the story, okay? That's the story, okay? So now, that is the story about optics, okay? Hope you got a good and nice idea about optics and how it works, okay? Seems like we don't have enough time to move into waves, okay? So if needed, let me know. I'll arrange a separate session for that. But that is the whole story about optics. What I needed was to give a very good idea about how it actually happens and how it actually looks like, okay? If you have a proper idea about how things happen, how it appears to be, what are the actual applications, instead of a rough idea of, okay, this happens like that, that happens like this. If I mean, the whole way of we teaching physics is wrong in O-level syllabus and in A-levels too, okay? The way many people demonstrate physics, these stuff should be explained. These stuff should be explained with the proper practical background, because physics is not just a bunch of diagrams, a bunch of lines, and a bunch of questions, okay? It's not about getting marks just for the examination. It's about understanding things properly, okay? Have that in your mind if you are planning to do science for A levels, okay? It's all about understanding things, okay? Understanding the world, okay? So hope you understood everything very well, okay? Hope you understood things very well. And we'll be meeting with more sessions, okay? I'll provide a channel link. You can go to that link and get all the previous sessions and tunes and everything. And please share it with your friends, okay? Please share it among all your friends so that everyone will be benefited, okay? Everyone will be benefited. I'll inform, most probably I'll go through a huge session on Monday to cover a lot of questions from the whole syllabus. I'll let you know about that. Until then, see you. Goodbye. And this is our hotline number if you need to know anything else and if you need any assistance other than this, okay? Not 70-154-6825. Not 70-154-6825. Okay? Contact our number if you need any assistance. Thank you and good night.